All right, it's time to do some good sleep behavior here. So we're going to go for Chapter 9 here. Hopefully you've got the book in Chapter 9, and I'm going to map a lot more in this particular presentation and the next one to things the book actually says. A little different for me. So the first idea I wanted to talk about is your sleep-wake cycle is one of a number of different cycles your body has. They're actually called circadian rhythms. And if you look on page 308 of your book, circadian means basically about a day. And if you look at figure 9.1, basically for things like body temperature and alertness and being sleepy and awake, temperature and cortisol levels, there's basically a cycle through the day that determines how awake and how sleepy you will be. It's actually been determined that our sleep-wake cycle actually isn't quite on a 24-hour clock either, that it's actually more like a 25-hour clock. Page 310, I think, says that as well, that you tend to have this tendency to want to stay awake a long time, an extra hour every day. So how do we know that these things exist? Well, have you ever worked the night shift before? If you have, you know that you get very tired in the middle part of the night, even though the lights are on and you're trying to stay awake in places. If you've ever flown long distances, I have two family members, actually now it's three. My dad, with his Parkinson's disease, is living in Hawaii, and so are my two sisters out there. So I've flown out there a few times, and the jet lag coming there and back is pretty miserable because it's really messing around with your circadian rhythms. We know there is a key structure in your brain that controls this. It's called the pineal gland, and it's actually located in your brain. I think your book actually states that particular gland. And another very importantly connected part besides that gland is an area called the suprachiasmatic nucleus. Of course, it's not the supracharismatic nucleus, it's the suprachiasmatic nucleus. It's right above the optic chiasm, and this seems to be the key structure that controls the light-dark cycle. From the pineal gland, there's actually a fair amount of melatonin there, and as it turns out, serotonin is the direct precursor of melatonin. So some of these ideas about serotonin, and some of you noted that melatonin can help produce some sleep. That's based on some of the functions of the suprachiasmatic nucleus and the pineal gland up in the brain. So we know these structures are very, very important. We also know that when you get light therapy, if you have seasonal affective disorder, that bright lights in many ways can really help set the clock up there for your circadian rhythms. They're actually going up to the suprachiasmatic nucleus. Looks like there's a nice little survey on page 309 about are you a lark or an owl, because many times people's habits really determine how good they can do things in the daytime and the nighttime. Next, what I wanted to talk about, moving ahead some in the book, is kind of the stages of sleep. It looks like pages 319 and 320. We'll kind of go into it. Looks like page 319. The way you can actually see what somebody is doing and what their brain is doing when they're sleeping is you hook them up to an EEG. And so there's a picture on page 319. I think I actually have one in your appendices too. You hook them up to see what stage they're in, and basically the EEG will record basically action potentials going on in your brain. It's non-invasive, it doesn't hurt, and when people are awake, it looks like on page 320, when you're awake, you basically have first alpha level activity. Actually, for me, it's always been beta and alpha. Beta and alpha waves are when your neurons are firing, but they're firing just randomly. So you get these waves that are very low frequency. Sorry, not saying this right. High frequency, low amplitude. So beta and alpha waves, when you're going to being awake to kind of being a little groggy, are high frequency, low amplitude type waves. Now, when you first fall into sleep, if you look at that picture on 320, you show theta waves. Theta waves are a little higher as far as their activity, but it's that lightest stage of sleep. You always know you're in theta sleep when somebody comes and starts talking to you and suddenly you wake up and you're like, oh, I must have been sleeping at that point. Moving along into stage 2, you have things called sleep spindles. These are brief periods of high activity. And then you have K complexes. If you look at the K complex in your book, to a electrophysiologist, that looks like the letter K, kind of going up and down. So they're called sleep spindles and K complexes. As you get more and more into the deeper stages of sleep, you start showing the waves that are known as delta waves. Delta waves are waves that are basically low frequency but high amplitude. That basically means the neurons in your brain are basically firing at the same time. And so you start seeing the waves go high and low and take a longer period of time. So these are called delta waves. And then the final stage, these are all considered non-REM stages, but the final stage is where you actually go into REM sleep. You actually go back up the ladder through the other stages, and you go into what's called REM sleep. And REM sleep is a period where many people consider you to be in your deepest stage of sleep. But if you look at the wave patterns there, it looks like beta and alpha waves. It looks like you're awake there, but it's also many times called paradoxical sleep because you're in your deepest stage of sleep, but it looks like, according to this, you're awake. And this is where you do a lot of your dreaming as well, is during the REM stage. So those are the patterns going through the sleep stages. During the night, stages 3 and 4 of the non-REM become longer, and so do the REM stages. And towards the morning, we'll have a lot more of that dreaming. As we get older, if you are a little older, like I am, in your 50s, REM in stages 3 and 4 get progressively less. Little babies, you have a lot of REM time there. So these are the patterns we have. REM sleep deprivation. How many of you have done the spontaneous experiments on REM sleep deprivation? There was one very famous study actually done on this. They took people at a very famous sleep lab. It was out in Stanford. And every time their EEG looked like they were going into REM, they woke them up. They wouldn't let them go into REM sleep. And if you've ever had this problem happen in your life, if you're deprived of REM sleep, attention, the ability to memorize, to focus, to have good personality traits is really, really disrupted if REM sleep gets interrupted. One of my favorite TV shows, has anybody ever watched Star Trek The Next Generation? There was one episode where they kept going into REM sleep and they kept being awoken there, so they all kind of went psychotic after a period of time. So if you're disrupted from this, it'll really cause problems for emotions, for memory, for attention, and so forth. And if you actually have this problem, in the study at Stanford, when they woke people up the first night when they went into REM, by the end of the night they were trying to go into REM on the first night of the study maybe 6 or 7 times. After doing this for a full week though, people were trying to go into REM sleep almost immediately after falling asleep, 20, 25 times. And then when they finally ended the study ethically, people went right into REM and they stayed in it a lot longer. So that's called REM rebound. So REM and sleep deprivation, add a few pieces of information from your books there. One of the ideas is, why do we need sleep and dreaming? And one of the ideas is the dreams are basically taking your daily events and kind of synthesizing them so you can make sense of them in your mind. We don't really know why we do all this sleeping and dreaming, but it seems to play an important function in our lives. So, with that being stated, let's see, I think we'll wrap up the first recording here. Thanks. Bye-bye.